So we're going to call this matrix modeling. How to build matrices. Matrices can be built in many contexts in our lived experience, from our lived experience. So the nice thing about, this is why I love applied math so much, because your life makes a difference. Like, life informs math. This is kind of a unique feature, right? In most of my math classes, I thought math was separate from life. But in applied math, the stuff that you experience every day actually can feed into your modeling intuition and can drive more interesting iterations as you get further and further into your modeling process. Let's take a look at a few of these situations. Take a look at a few modeling scenarios. We can use to construct matrices. And that's what we're going to do in all of lesson 7. Before we begin with that, though, I think it's important that we have a formal definition of what a matrix is, because this wouldn't be a math class without definition, right? So this is 3.1, and we're going to call this the entry by entry definition of an M by N matrix. So the first thing that we do when we start with this definition is we let these things be dimensions. And we say that an M by N matrix A in Rm by N is a rectangular array of real numbers, and perhaps we actually say the number of scalars that we need. We're going to need m times n scalars. This is a set of m times n scalars that are organized into, can you guess how many rows and how many columns? M rows and n columns. And the claim on this is when we're writing this m times m, what always comes first? Number of rows, and what comes second? Number of columns. When we write an m by n matrix, we write the general structure as the following matrix. So now we have A equal to, I like to use braces on my matrices. Some linear algebraists will use parentheses. Perhaps it's a function of my undiagnosed OCD that I really like the straight lines, or maybe I just don't like differential curves, I don't know. But I really like braces. I find them to be quite satisfying emotionally and intellectually. So you'll see that, and I would encourage you to kind of play around with them, right? So in this case, we have A11, A12, all the way down to A1n. Well, how do I know that there's n different columns? Because it was an m by n matrix, meaning to say that I have, in each row, I have n columns. Could you guess what the next row is? A21, A22, all the way down to A2n. How many total rows do I have? M of them. So the first entry in the mth row, in the mangoeth row, would be what? M1, M2, all the way down to Mn. So that's now M by N matrix. We said this was the entry by entry definition because we literally specified every single entry in defining A, the matrix A. What do I mean by that? How many different entries would I have to define in order to construct this matrix? In row 1, I'd have to define n of them. In row 2, I'd have to define n. In row 3, n. All the way down to the last row, which I would have to define n of them. There are a total of m rows, so how many total entries would I have to define? M by n. Each entry is called each individual scalar value, aik, is called an entry, element, or coefficient of our matrix.